Today, we are going to look at an important laboratory glassware used in spectrophotometry, which is called the cuvette. We'll start by looking at what a cuvette is. A cuvette is a laboratory glassware or equipment that is used to hold samples for spectroscopic analysis. And what we also have to note is that the cuvette has two sides, and these are the clear sides and the opaque or the frosted sides as seen here. Types of cuvette. Basically, we have three main types of cuvette. These are the glass cuvettes, the quartz, and the plastic cuvette. And what we have to note is that the quartz and the glass cuvettes are used when organic solvents are involved because they have higher resistance to organic solvent as compared to the plastic cuvette. So in general, the quartz and glass cuvette display greater transparency and accuracy of measurement, and they can be reused times over the plastic cuvettes. So let's take them one by one and look at them. So we'll start by looking at the plastic cuvette. So first of all, what we have to notice is that the plastic cuvette is plastic in nature and manufactured from polystyrene, which is a plastic polymer. Compared to the glass and the quartz cuvette, the plastic cuvette can't be used when working with organic solvent and is only best used in the visible range. That's a wavelength between 400 nanometer to 700 nanometer, because the plastic cuvette does not allow the absorption of light best below 400 nanometer and above 700 nanometer. And finally, it is not best for reusing. The advantage of the plastic cuvette over the glass and the quartz cuvette is that it's less expensive. So this is how a plastic cuvette normally looks like with different shapes. So this is a shape and this is also a different shape, but they are all plastic cuvettes made from polystyrene, which is a plastic polymer. Effect of using organic solvent with plastic cuvette. So what we have to notice is that the organic solvent will react with the polystyrene in the plastic cuvette to form foggish substances on the surface of the cuvette. So as you can see from these two pictures, this is our clean or transparent cuvette, and this is our foggish cuvette. And this happens as a result of organic solvent reacting with the polystyrene in the plastic cuvette to form these foggish substances that we are seeing over here on the surface of the cuvette. And when this happens, the cuvette becomes opaque. You can't really see through or see through well. Glass cuvette. The glass cuvette is glass in nature, and it is used for measurements in the wavelength range of 340 nanometer to 2500 nanometer, and it can be reused unlike the plastic cuvette. So as you can see over here, this is our glass cuvette, which is made of a glass material, and these are the opaque sides of the glass cuvette, and these are the clear sides. And it has a wavelength range from 340 nanometer to 2500 nanometer. The quartz cuvette. Quartz has the has the capability of more light transmission and is more transparent than the glass cuvette and plastic cuvette. So it is used for sensitive experiments. It's also more resistant to changes in temperature, and it's used for measurement in the wavelength range 190 nanometer to 2500 nanometer. Also, the quartz cuvette is more ideal for concentrations and purity measurements than the glass and the plastic cuvette. So as you can see over here, this is the quartz cuvette over here, which is made up of a quartz material, and has a wavelength range from 190 nanometer to 2500 nanometers. So let us look at some keynotes. The first is what happens if a cuvette is dirty, or what happens if you use a dirty cuvette. So what you have to note is that less light will reach the test sample in a dirty cuvette. This is because the dirt on the cuvette will absorb portion of the light, adding to the amount of light absorbed by the sample itself to give a false higher absorbance value of the sample. The next, what happens if you use a scratched cuvette? The scratches will cause light to scatter and will ultimately affect your measurements. And what happens if there are bubbles in the cuvette? The light beams from your monochromator will pass through the air instead of your sample solution to give inaccurate absorbance reading. And to get rid of these air bubbles in your cuvette, you only have to tap the opaque sides of the cuvette with your fingertip gently and slowly to remove all the air bubbles in your test solution before measuring the absorbance. Next, what happens if there are fingerprints on the cuvette? The fingerprints will interfere with light transmissions to cause inaccurate measurement and lead to a slightly higher absorbance reading because the fingerprints will absorb part of the light. So now let's look at what a cuvette path length is. So when we talk of a cuvette path length, is the inner distance between the cuvette clear wall. So as you can see over here now, so this is the clear side of the cuvette, and there's also a second clear side over here. So the inner distance between these two clear sides is what is termed as the path length, or it can be defined as the distance that light travels through a test sample in a cuvette. So this is our cuvette over here containing our test sample. So the distance from the clear side that the light will travel through in a test solution is what is termed as the path length. How does cuvette path length affect absorbance? So first of all, we know that absorbance is directly proportional to the concentration of our test solution and the path length of the cuvette used from Beer-Lambert's law as seen over here. So hence, a higher cuvette path length will allow maximum absorption of light to produce higher absorbance readings. So these are different cuvettes, various cuvettes with different path lengths. Using the cuvette. So the first thing that we have to note before we use the cuvette is that in terms of volumes is that always fill the cuvette to about 80% of its total volume with the test solution you wish to test. So as you can see over here, these are our test solutions filled to about 80% of the total volume of the cuvette. The next is to use the same cuvette for every measurement. And why do we have to use the same cuvette for every measurement? So first of all, in order to obtain the most accurate and reproducible result, the blank and sample should not be measured using different types of cuvettes since they may have different path length. And as explained earlier, we know that absorbance is directly proportional to the path length. So if you happen to use different cuvettes that might have different path length, you will end up getting wrong absorbance readings. So as you can see over here, so this is a picture showing the use of two different cuvettes for a measurement, which is wrong. Though they are both plastic cuvette, we can see that they don't have the same shape. So it might be that maybe the path length for this cuvette is 1 centimeter and that of this is 1.5 centimeter or millimeter. So using these two different cuvettes for reading in an experiment, you will end up getting a wrong result because of the difference in their path lengths. Handling, cleaning and storage of cuvettes. Let's start by looking at handling of cuvettes. 1. Handle the cuvettes carefully to avoid breakages since they are fragile. 2. Avoid contact with clear sides of the cuvette with any hard surface to avoid scratches, as these may reduce light transmission. So as said earlier, these are the clear sides of the cuvette and these are the opaque sides. So when you want to handle it, you must avoid touching the clear sides to cause any form of to cause any form of scratches on it or introduce contamination on it. So the next is that we are to hold the cuvette in such a manner that the opaque sides are held between two fingers. So as you can see over here, so this is the clear side of the cuvette and these are the opaque sides between two fingers, and the transparent sides are not being touched. Yeah, so as you can see over here, this is a good student holding the cuvette in such a way that the opaque sides are held between his two fingers without touching the transparent or the clear side. 4. Hold the cuvette by the top to avoid any scratches or damages to the lower part where light is transmitted through. Yeah, so this is the best way to hold the cuvette. So we normally hold it by the top and we hold it at the opaque sides. 5. Fill the cuvette with a sample solution before inserting into your sample holder of the spectrophotometer. So as you can still see from here, this good student has filled his cuvette with his test solution before putting it into the spectrophotometer for analysis. 6. Before keeping the cuvette inside the holders, always blot them from all sides, that is both clear sides and both opaque sides, with clean wipes or soft tissue towels or lint-free tissue. 7. While inserting the cuvette into the sample holder, avoid applying excessive force. 8. Always ensure that the transparent sides of the cuvette are in the optical path. And 9. Always use the same type of cuvette for your blank and sample reading. And one thing that you also have to notice that when we talk of the optical path, is the path through which your light or your monochromatic light will pass through your cuvette onto the detector. Importance of using gloves. So first of all, what we have to notice that one important aspect of cuvette handling is the use of gloves. What we also have to notice that gloves are essential in preventing contamination and fingerprints on the cuvette, which can affect the accuracy of the result. Gloves also protect the cuvette from scratches and chipping during handling, and also touching the cuvette with bare hands can leave oils and other residues that can interfere with the readings. Now let us look at the cleaning of cuvettes. 1. If cuvettes appear clean, simply rinse several times with distilled water, then once with acetone if it's a glass or quartz cuvette, in order to prevent watermarks, and leave to air dry in an inverted position, example on a tissue, before use. 2. If solution measured is aqueous, wash the cuvette with the blank solution under use, followed by several washings with distilled water. Dry the cuvette by blotting them on a tissue paper. And what we also have to notice that before use, cuvette should be cleaned to remove any accumulated residue or contaminant. 3. If the solution measured is non-aqueous, clean the cuvette with the blank solution under use, followed by several washing with solvent which is miscible with the blank, and give a final washing with distilled water and blot the cuvette on tissue paper to air dry. And what you also have to notice that if cuvette, which is either a glass or quartz, do become heavily swelled, then the following solutions are recommended for soaking before cleaning. 1. A mild non-alkaline detergent, and the concentration is used as specified by the manufacturer. 2 is 10% acetic acid. 3, concentrated nitric acid, which is 50% volume by volume of the acetic acid. Storage of cuvette. The best way to store cuvette immediately after cleaning is the use of a plastic cuvette rack. So this is a plastic cuvette rack as seen here, and this allows the cuvette to dry completely after cleaning and ensures they are stored securely. The ideal storage place for quartz and glass cuvette is their transport or storage box. So this is a transport or a storage box for the quartz or the glass cuvette, as this keeps them safe from contamination, scratching, and chipping. Additionally, cuvettes should only be handled with gloves during storage to avoid fingerprints. Inappropriate storage of the cuvette. Improper storage of cuvette can lead to contamination, scratching, and chipping. In general, cuvette should not be stored in the sample holder of the instrument, as this can cause damage to the cuvette and affect the accuracy of the result. So, as you can see from this picture, this is a bad student who has decided to store his cuvette in the sample chamber of the spectrophotometer. And what we also have to notice is that the quartz cuvettes and glass cuvettes should never be stored loose. Example, in a drawer, as this can cause scratches and chips, which can affect the accuracy of the result. And what we also have to notice is that the plastic cuvette racks should not be used for long-term storage. The transport bus. So this is how the transport bus looks like. Some may also come in a different shape and form. The transport bus is designed to protect glass or quartz cuvette from physical damage and contamination. The transport bus is made up of sturdy materials that shield the cuvettes from external pressures and keep them safe during transportation. It also has a secure locking mechanism that prevents the cuvettes from falling out, getting lost, or getting mixed up with other cuvettes. Also, it provides a clean and sterile environment for the cuvette. The bus is usually lined with a soft material that prevents scratching and contamination of the cuvette. Thank you.